Welcome back. Today we're talking about Chapter 11, Multi-Step Equations and Inequalities, and focusing on Lesson 5, Solving Inequalities by Adding or Subtracting. Inequalities with variables may have more than one solution. All the solutions of an inequality are called a solution set. And a set is sometimes just a word used for a group of numbers. So all the solutions of an inequality are called a solution set. You can solve an inequality involving addition or subtraction just as you would solve an equation. So all the skills you learn to solve equations, you can apply those same skills to solving inequalities. So let's look at these problems right here, these first two. We are going to complete the steps to solve, graph, and check the inequality. So on number 1, we have n minus 13 is less than 7. So just like equations, we're trying to isolate n and get n by itself. Well, is n by itself? No, it is not. And the inequality, you can kind of think of it just like an equal sign. Okay. So solving this would be kind of very the same as solving this right here. So what would we do to get n by itself? Well, we'd have to get rid of the 13. How is the 13 related to n? It's related to n through subtraction. So we do the inverse operation, which would be add 13 to both sides. And you can treat this inequality sign as if there's two sides of the inequality. This is one side of the inequality, and this is the other side of the inequality. So it's kind of just the same as solving an equation. So we want to get n by itself. There's 13. 13 is related through subtraction, so we're going to do the inverse operation, which would be to add 13 to both sides. This negative 13 and that positive 13 equals 0, so they end up canceling each other out. And then we're left with n is less than 7 plus 13 would be 20. Okay, so that is our solution. N is less than 20. So we're going to graph it. I'm going to find 20. This does not include 20. It's less than 20, so we're going to have an open circle. And then n is going to be all of the solutions that are less than 20, which would be here, all of these numbers. All right, now what we're going to do is we're going to check it. Now, how we check it is we just pick any number from the solution set. So the solution set is not including 20, but it's everything this way. So we can just pick any of these numbers. I want to just go ahead and let's pick 10. So I'm going to say n equals 10. And I'm going to plug 10 in for n. So 10 minus 13 is less than 7. So what is 10 minus 13? Well, 10 is a positive and 13 is a negative number. So the signs are different. We take the difference. And the difference between 13 and 10 is actually 3. And then we have to figure out, not looking at the signs, which number is bigger, and 13's bigger, and 13's negative, so our answer is a negative 3. So when we look at this, negative 3 is less than 7. Is that a true statement? Yes, that is a true statement. What that means is that n equals 10 is a solution to this inequality. All right? Now, we could pick a different one, a number of the solution set. How about we just pick 0? Okay, so I'm going to do this process again. I'm going to write my original inequality. N minus 13 is less than 7, except now I'm picking a different one because there's really a lot of values that n can equal. It can equal anything. It's like almost an infinite amount of values that it can equal. So I'm going to choose 0 because it's a part of the solution set. I'm going to go ahead and plug 0 in for n. And then that's just negative 13. And negative 13, is that less than 7? Yes, it is. That's a true statement, which means that n equals 0 is a solution of this inequality as well. All right, just to, so we talked about true. Let's go ahead and pick one that is not a part of the solution set. So how about we choose, let's go with 30. 30 is not a part of the solution set. Let's see what happens when we check with a number that is not a part of the solution set. So I'm going to rewrite the inequality. n minus 13 is less than 7, except now I'm going to be looking at when n equals 30. Okay? So I'm going to plug 30 in for n. 30 minus 13 is less than 7. And then I'm just going to do this. This is positive, that's negative. So I'm finding the difference. 30 minus 13. The 0 is not big enough, so I need to borrow from the 3, making that a 2 and that a 1. 10 take away 3 is 7. 2 take away 1 is 1. So I'm left with 17. Yeah. So is 17 less than 7? No, that is false. That means that n equals 30 is not a solution. Okay? So if you put a number in and you get a false, something that's a false statement, that means whatever number you stuck into the inequality is not a solution. Where up here, we took numbers that were a part of the solution set, we plugged them in, and we have true statements. That means that both of these numbers are a part of the solution set. Okay? You see how that works? Perfect. Let's go on to number 2. So number 2, we have x plus 18 is greater than or equal to 2. So we're trying to isolate and get x by itself. So we're just really going to think of this as an equal sign. It's not, but we're going to treat it as it is. So these are the two sides of the inequality. I'm trying to get x by itself. Is x by itself? No, it is not. What's around it? 18. How is 18 related to x? Through addition. So we're going to do the inverse operation of addition, which would be subtraction. We're going to subtract both sides by 18. So this positive 18 and that negative 18 end up canceling each other out. I'm left with x by itself on this side. It's greater than or equal to. And then I have 2 minus 18. So 2 is positive, 18 is negative. The signs are different. You take the difference. So we're going to take the difference between 18 and 2. Whenever you're taking the difference, you ignore the signs, and whatever number is bigger, you always put that one on top. So I'm not thinking about this being a positive 2 or thinking about this being a negative 18 at this point. I'm just looking at the numbers 18 and 2. 18 is bigger. I put that on top, and then I go ahead and find the difference between the two numbers. So 8 minus 2 is 6, and then I just drop the 1 down. So it's 16, but I had to figure out, is it a positive 16 or a negative 16? So I look at the two numbers, independent. I'm not looking at the signs, right? I'm not looking at this as positive and this is negative. I'm just looking at 2 and 18. And 18 is a bigger number, 18 is negative, and so that means that my answer is going to be negative. So the solutions for this solution set would be x is greater than or equal to negative 16. So I'm going to go ahead. This is greater than or equal to, so that's going to be a closed circle. I'm going to go to negative 16, put in that closed circle, and then x is bigger. So all the numbers that are bigger than 16 would be this way. All right? So now we're just going to go ahead and check it. So we're going to pick any number that's a part of the solution set. Just to keep things simple, I'm going to choose 0. 0 is a nice number. So I'm going to say x equals 0, and I'm going to plug 0 in there for x. 0 plus 18 is greater than or equal to negative 2. Well, 0 plus 18 is just 18. And is 18 greater than or equal to negative 2? Yeah, this is a true statement, which means that x equals 0 is a solution to the inequality x plus 18 is greater than or equal to negative 2. Okay, that's what that means. All right, let's move on. Go ahead and turn the page. Let's move on to problem number 3. And we're just going to go ahead and solve these and graph. So solve, then graph each solution set. So we're trying to figure out what D is. We have number 3 is D plus 3 is greater than negative 5. So we're trying to isolate D. We're going to treat this as an equal sign, so which splits the inequality into two sides. We're trying to get D by itself. Is D by itself? No, it's not. So we have to get rid of this 3. Well, how is this 3 related to D? It's related to D through addition. So we have to do the inverse operation, which would be subtraction, to both sides. This positive 3 and that negative 3 cancel each other out. We're left with D is greater than. And then we have negative 5 minus 3. Well, 5 is negative and 3 is negative. So remember, whenever you have two negatives right here and you're kind of adding them together in a way, you keep the sign and then you just add the numbers. 5 plus 3 is 8. So there you go. And now we're just going to graph it. So D is greater than negative 8. So I'm going to go find negative 8. It is not equal to it, okay? So it does not include negative 8, so it's going to be an open circle. And D is greater than negative 8, so all the numbers that it's greater than would be here, this way. Okay, so that's how you graph it. All right, so now what I want you to do is I want you to go ahead and work on number 4, solve it and graph it. Okay, where's my friend? Oh, here's the pause dragon. So work on 4 only. When you get done, I want you to go ahead and pause right now. There's our friend, the pause dragon, reminding us to pause your device. And when you get done with number 4, press play, and then we'll check your answer. All right, see you in a bit. All right, well, we are back. Let's go ahead and see how you did. So we are trying to get S by itself. We have S minus 10 is less than negative 6. So we have this inequality, which splits the inequality into two sides. We're going to, S is not by itself. We have to get rid of this negative 10 by doing the inverse operation, which would be adding 10 to both sides. That cancels out and becomes 0. We have S is less than negative 6 plus 10. 6 is negative, 10 is positive. The signs are different, so we take the difference. And so we're going to take the difference between 10 and 6. The difference between 10 and 6 is 4. And then we're going to look and see which number is bigger. Is 10 bigger or 6 is bigger without paying attention to the signs? 10 is a bigger number and 10 is positive, so that means our number ends up being positive. Perfect. Now we're going to graph it. So we're going to find 4. It's going to be an open circle, and S is less than 4, so it's going to be this way. So that's if you got that right, great job. Okay. Let's go down to 5, 6, and 7. I want to do 5 together, and then I'm going to have you do 6 and 7 on your own. So let's go ahead. We are trying to solve for y. You have to get y by itself. So right now it is not by itself, so we are going to do the inverse operation of a positive 9, which would be a negative 9 to both sides. Those cancel out. We're left with y is greater than 20 minus 9 is 11. So there you go. There's our answer right there. Okay, but now we're going to check it. Okay, so I'm going to write the word check. I'm going to write the inequality down, the original inequality. Okay, and now I'm going to pick a number that is a part of the solution set. So y has to be greater than 11. So our answers may vary on this, but I'm just going to pick any number that's greater than 11. So I think I'm going to choose, how about, I'll choose, I don't know, 12. 12 is bigger than 11. So y is going to equal 12. That means 12 should be a part of the solution set. So I'm going to put 12 in here for y. So I have 12 plus 9 is greater than 20. And we're going to see if this is correct. So I need to add those two numbers. I'm going off to the side to do that little work here. 9 plus 2 is 11. So write the 1, carry the 1. And 1 plus 1 is 2. So I have 21 is greater than 20. And 21 is greater than 20. So that's a true statement, which means that y equals 12 is a solution. Now, it's not the solution because there's a lot of solutions. So it's one of the solutions. It's a solution of the inequality y plus 9 is greater than 20. Okay? So there we go. So now I want you to go ahead and do 6 and 7 on your own. You're going to solve them, and then you're going to check them. Now, when we come back and I do a check, you might pick a different number than I do, and so our checks may vary a little bit. But yeah. Okay, where's our friend the pause dragon? Oh, here he is. Okay, or she, I don't know. It's a pause dragon. So go ahead and press pause, work out 6 and 7. Remember to do the checks. And when you get done, press play, and we will see how you did. All right, see you in a bit. See you in a bit. Okay, we are back with problem number 6. I'm going to go ahead and kind of just make a line separating these two problems. Okay, we are trying to isolate h and get h by itself. So to do that, it is not by itself on this side of the inequality. Right now there's this plus 11 over here, so we have to do the inverse operation of addition, which would be subtraction. Those cancel. We're left with h is less than or equal to negative 6 minus 17. Okay, so we have two negatives here, and we're adding, so we know that our answer is going to be negative, and then we just need to add 6 plus 17. So 17, I'm doing that on the side. 17 plus 6, 7 plus 6 is 13. Write the 3, carry the 1. 1 plus 1 is 2. So it's a negative 23. So that's what h equals. H equals... Oh, no, I'm sorry, not equals. H is less than or equal to negative 23. So now we're going to check it. Okay, I'm going to write the original inequality. H plus 17 is less than or equal to negative 6. And then I'm going to sub in negative 23 for h. Negative 23. Oh, and I'm not doing that. I'm going to pick a number that is less than negative 23 or equal to. So I guess I can do, it can be equal to it. So I'm going to try it equal. H, I'm going to say equals negative 23. So I'm going to substitute negative 23 in for h. So I have negative 23 plus 17 is less than or equal to negative 6. Okay. So I have negative 23 plus 17. So this is a negative. This is a positive. I need to go ahead. The signs are different, so I need to take the difference between 23 and 17. To do that, I'm not going to look at their negatives or positives right now. I'm just going to look at 23 as a number and 17 as a number, and I'm going to take the difference. So I'm going to put 23 on top and subtract 17 from it. The 3 is not big enough, so I need to borrow from this 2, making that a 1. And then that's going to be 13 minus 7, which is 6. And then 1 minus 1. So negative 23 plus 17, it's going to be a 6. But I need to figure out if it's going to be a positive or a negative. So I look at the 23 and the 17. 23 is a bigger number. 23 is negative, so that means our answer is going to be negative. So we have negative 6 is less than or equal to negative 6. And that is a true statement because of this equal bit. Negative 6 is equal to negative 6. So there you go. That means that this is a solution of this inequality here. Okay. Let's move on to number 7. So on number 7, we are trying to get a by itself. And at the moment, it's not by itself, so we need to get rid of this negative 4. So we're going to do the inverse operation of adding 4 to both sides. This negative 4 and that positive 4 are going to cancel each other out. We're left with a is greater than or equal to negative 18 plus 4. So we have a negative and a positive again. So the signs are different. We take the difference. So I'm going to take the difference between 18 and 4. 8 minus 4 is 4. Drop the 1, it's 14. And then I look at these two numbers. Which one's bigger? 18 is bigger and it's negative. So there we go. It's going to be a negative 14. So a is going to be anything greater than or equal to negative 14. So I'm going to check it. Rewrite the inequality. A minus 4 is greater than or equal to negative 18. And I'm going to pick one that's really, really super easy. How about a equals 0? Okay, 0 is greater than negative 14. So I'm going to stick in 0 for a. 0 minus 4 is greater than or equal to negative 18. And then that's just negative 4. Yeah. And negative 4 is greater than or equal to negative 18. So negative 4 is closer to 0 than negative 18 is. So this is a true statement, which means that a equals 0 is a solution to the original inequality right there. All right, if you got those right, great job, and we will see you next time.